Different type of fractions you are learned in the 5th class or 6th class, addition, subtraction, so and so. Okay, these fractions, why we are taking the discussion about the fractions? 11 by 2, that is a fraction. 1 by 2, that is a fraction. So, why we are taking the discussion about the fractions? Because we are going to take the definition of rational numbers. These are nothing but fractionals only we are getting. Okay. Just I will write the definition of rational numbers on the board. See all of you. So what are rational numbers? The numbers which can be expressed in the form of P by Q, and that is Q not equal to 0. The numbers which can be expressed in the form of P by Q are called rational numbers. Okay? These are indicated by the letters capital Q. The numbers which can be expressed in the form of P by Q. The numbers which can be expressed in the form of P by Q are said to be rational numbers. And must you know that Q not equal to 0. In the fraction P by Q, P comma Q are any two integers you can take. Okay, either negative or positive, whatever it may be. P comma Q are integers and Q not equal to 0. The numbers which can be expressed in the form of P by Q are called rational numbers. So, in the previous example you taken 11 by 2. 11 by 2 is a fraction. You think P is equal to 11 and Q is equal to 2. P by Q. So, it is a fraction. These numbers are said to be rational numbers. Okay, rational numbers are indicated by which letter number? Q. Quotient number. While the division you are getting the quotient. That's why you can say quotient numbers also. Right? So these are indicated by capital Q. I am writing the example of rational numbers. Any fractions you can write, for example 11 by 2 or 3 by 4 minus 5 by 6. Right? And minus 3, 10, 0, 15, etc. etc. These are all rational numbers. But the numbers which can be expressed in the form of P by Q, that is in the fractional numerator, denominator you are looking. And here 11 by 2, okay. 3 by 4, minus 5 by 6, these are fractions P by Q. But what can we say about minus 3 or 10 or 0 or 15, etc. etc. All the numbers you can indicate by the fraction also. CM. Minus 3 means minus 3 by 1. You can write. And 10 by 1 or 0 by 1 or 15 by 1. These are also P by Q form. Understand? Minus 3 by 1 P by Q. 10 by 1 P by Q. 0 by 1 P by Q. 15 by 1 P by Q. That's why these are also rational numbers. This minus 3, 10, 0 or 15, these numbers also you can indicate in the form of P by Q. Understand? These numbers also you can indicate in the form of P by Q. So these are also rational numbers. Now you understand natural numbers, whole numbers, integers, rational numbers. In the rational numbers, all the numbers are repeating amount. Rational numbers, all the numbers are repeating. Natural numbers are there. 1, 2, 3, 4, etc. etc. Whole numbers, 0 is also there. In the rational number, 0 also there. Right? And integers, negative numbers also there. Minus 3 or minus 5 by 6, so and so. Negative numbers also there. So, rational numbers includes all the set of numbers. Rational numbers includes all the set of numbers. That's why rational numbers are bigger than all the numbers are. Rational numbers are bigger than all the numbers. Understand? In the rational numbers, natural numbers are there, whole numbers are there, integers are there, and rational numbers. Fractions also there, p by q form. So that's why the numbers which can be expressed in the form of p by q, q not equal to 0, are called rational numbers. Rational numbers are indicated by which letter? Capital Q. Q is equal to 11 by 2, 3 by 4, minus 5 by 6, minus 3, 10, 0, 15. As your time, you can write any examples. But those numbers must be in the form of p by q. Understand all of you? Rational number means that should be in the form of p by q. Those are perfectly rational numbers. So these are the different set of numbers. So before starting rational numbers, that's why we have learned the basics. Natural numbers, integers, and whole numbers, integers. Okay. Then next we came to rational numbers. Right? Now these numbers are having different properties. Rational numbers mean the natural numbers, whole numbers, integers, all are having properties. That is closure property, associative property, distributive property. Understand? So rational numbers, these are also having different properties. But all the properties we should check for the four fundamental operations. So what are the four mathematical operations, fundamental operations we can say? So what are the four mathematical fundamental operations? Addition, subtraction, multiplication and division. These are the four fundamental operations. For each law, for example, we can take closure property or closure law. That should be applicable in addition or subtraction or multiplication or division. Like that we have to verify. Okay? Now all of you understand what are rational numbers? You perfectly remember this definition of all of you remember carefully. Okay? What are rational numbers? The numbers which can be expressed in the form of p by q are called rational numbers. And rational numbers are indicated by the letter capital Q. Okay? And q is equal to any examples you can take. Now you perfectly understand all the natural numbers are also said to be rational. Understand all of you? 1, 2, 3, 4 all are rational numbers. All whole numbers also rational numbers. 0 is also a rational number. And all integers also said to be rational numbers. Minus 3, that is an integer. You can say that is a rational number because minus 3. You can write minus 3 by 1 also. Understand? All these are also rational numbers. And our topic is rational numbers. And we are going to discuss some different properties of rational numbers as well as in the addition, subtraction, multiplication and some more applications of the rational numbers in this chapter we are going to discuss. Okay? Now just it is the definition of rational number. Right? Okay. And the next part we are going to take is the properties. Sorry. Properties of rational numbers. Let us see. Properties of rational numbers. Properties of rational numbers. Okay, first one we are told. Closure property. Closure property. In the 6th class and in the 7th class there are closure property. Okay. If A comma B are any two rational numbers, A plus B, A minus B, A into B, A minus B, and A divided by B also rational. That is closure property. And in the rational numbers only, suppose in the natural numbers, just first we are discussing about natural numbers. In the natural numbers, a plus b and a into b only natural numbers. In the place of a and b, any two examples we can take up. It is the first name of the property is, if a comma b are any two rational number, a plus b or a minus b, a into b, a divided by b also a rational number. See here. For example, a is equal to 5 or b is equal to 2, we are taking. See all of you, observe here, a is equal to 5, b is equal to 2. Here 5 is a rational number, 2 also a rational number. Okay, first one, a plus b. 5 plus 2 is equal to 7. It is rational or not? Yes, it is a rational number. Next, a into b. 5 into 2. 10 is also rational number. The next 5 minus 2, sorry, a minus b, that is 5 minus 2, 3 is also rational number. And a divided by b, that is 5 by 2, 5 by 2 also rational number. Understand? So, rational numbers, closure property is applicable in addition, multiplication, subtraction and division. Just we are taking the properties of rational numbers only, that's why we are taking 4 fundamental operations: addition, multiplication, subtraction, division. Okay, it is the form of closure property. Just it is the form of closure property. If a comma b are any two rational numbers, a plus b also rational, a into b also rational, a minus b also rational, a divided by b also rational. But all of you listen carefully. For natural numbers and whole numbers, closure property is not applicable in subtraction and division. In the subtraction and division, closure property is not applicable for natural numbers and whole numbers. Because, for example, a is equal to 5, b is equal to 2 means okay. Suppose you are taking a is equal to 2 and b is equal to 3. Okay, a plus b, okay, 2 plus 3, 5, that is natural number. A into b, 2 into 3, 6, it is also natural number. Okay, what can you say about a minus b amount? 2 minus 3. 2 minus 3 means what? Minus 1. Is minus 1 is a natural number? No, minus 1 is integer. So, a divided by b, 2 by 3. 2 by 3 is a rational number, that is not natural number. That's why this closure property in addition and multiplication are applicable for only natural numbers in addition and multiplication. Understand? For the rational number, okay. For the rational numbers, closure property is applicable for addition, multiplication, subtraction and division. But closure property is applicable for natural numbers and whole numbers only in addition and multiplication, not in the subtraction and division. Understand? It is the first form of closure property. In the properties of rational number, it is the first property of closure property. If a comma b are any two rational numbers, their sum a plus b, their product a into b, their difference a minus b, the quotient a by a divided by b also a rational number. Just it is the example for the properties, that is a plus b, a into b, a minus b and a divided by b. Any numbers you can take, not only a is equal to 5 or b is equal to 2. You can take any examples and you can write. It is the first property, closure property, and the next commutative property and associative property. The more properties are there, so we are going to discuss in the next class. And just today we are discussing about the fundamentals of set of numbers only. Natural numbers, whole numbers, integers, and as well as the main topic is rational numbers. Okay? And just we are introduced to the properties of rational numbers. In the properties of rational numbers, only the first property, closure property. Understand? Right. So these are the topics we are discussing today, and in the next class we are going to discuss about some more properties of rational numbers. Okay, Amma? Right. Okay. Thank you, children. Thank you very much, and we will meet you tomorrow. That is in the next class. Okay. Bye.